It's a pretty well known fact that our sun will eventually die. It's constantly becoming larger and larger, and it will eventually swallow half of our solar system, maybe even including Earth. However, the fate of a star highly depends on its size and its type. Even though our sun is insanely big when, for instance, compared to Earth or other planets of our solar system, our sun really is not all too big when compared to other stars. There are stars over 100 times its mass elsewhere in our galaxy, for instance. The bigger the star is, the shorter its life is going to be, because massive stars convert their hydrogen fuel very quickly. We've got three types of stars, and before we get into those, I think it's important that we talk about what the main sequence is. The main sequence is basically a period in which all of the stars spend 90% of their lives. After the main sequence, there are three main types of outcomes. Type 1 are low mass stars. These stars will eventually collapse and evolve into small, dim black dwarfs. However, due to their small size, the rate of their hydrogen usage is very low, which is why this process takes billions of years. Type 2 are sun-like stars. These stars will eventually evolve into red giants. After some time, the outer layers will start to form planetary nebulae, and in the end, they will collapse, becoming very small. They will end up as white dwarfs inside planetary nebulae. Finally, Type 3 are high mass stars. These stars evolve into supergiants. This happens because at some point the nuclear fusion reactions stop occurring within the supergiants, and there's simply not enough pressure from within them to counter the force of gravity. At the ends of their relatively short life cycles, they explode in a supernova. Now, depending on the size of their remnants, they will either become neutron stars or black holes. If the stellar core that remains is less than 3 solar masses, it becomes a neutron star. These stars are insanely dense and they spin incredibly fast, creating an immensely strong magnetic field. Some may even emit two beams of radio waves from their magnetic poles, and if that's the case, they're known as pulsars. Of course, if you're curious what would happen if you, for instance, touched the neutron star, this guy here tried it, so you can have a look. Link in the description, of course. On the other hand though, if the stellar core is larger than 3 solar masses after the supernova, the collapse of the star simply cannot be stopped, and then a black hole is born. Not much is known about them due to their characteristics, and we know that not even light escapes them, which renders them very difficult to observe. But we've made some observations, and you probably remember this picture. It's quite crazy to think that this can even happen to stars. Our sun is one of the main reasons why life even exists on this planet, and yet we won't really notice much of a difference in its size during our brief lives anyway. However, many million years are really nothing in space, which is why you could even say that stars live pretty brief lives. The information in this video was taken from this book, and I'm not sponsoring it or anything, but it's a very good book. It's a good book. I recommend reading it. It's good.